Okay, Elise. Looking at this question for you, it does require the answer from question 10. So I'm just going to write the answers from question 10 down there so that we can refer to them. You seem to have done them all right, so that's good. So question A for the surface area was 16,800 square meters, and question B was for the volume, that was 84,000 cubic meters. Now, you did ask about question B, so I assume you did question A all right, but I'll do it now just so that we're on the same page. So to do question A, you used the trapezoidal rule twice. So you had the width is 120, and then the first length and the last length was 0 and 100. And then obviously you're doing that with the second application as well. And that was 100 and then 80 were your two lengths. So you put it into the trapezoidal rule formula and you will get 16,800 meters squared. So that's how you did 10A. Now, I did that in question 11 because I didn't have that data, so I thought I'd better do it. Now, you had to work out what the volume of water in the reservoir was after the rain. Now, the volume is the surface area times the amount of rain, or the height. So we're going to do 16,800 times the rain was 150 millimeters, but we're going to convert it to meters so that we've got them all in the same unit. So it's 0.15 meters. Multiply that out and you get 2,520 cubic meters. Now, obviously, that is just from the 150 millimeters rain. So we have to do that 2,520 plus the 84,000 that we got from question 10B, which gives us the actual total of 86,520 cubic meters. So from what I can tell from your email, you actually did that and got that right. So that's not a problem. So we're moving on to question B, and this is the one where you had the issue. So reading it says, after the rain, the farm that depends on the reservoir needs an extra 15,000 cubic meters of water. Then the next bit says how much rain needs to fall in that time so that the water level in the reservoir remains the same after they've pumped that extra water out. So in other words, we want to get back to the 86,520. So we don't want that to change. So they're just adding an extra 15,000. So to be honest, we can actually ignore question 11A. We don't need that. All we're really worried about is how much rain do we need to get 15,000 cubic meters of water. Okay, so the rest of it doesn't matter because we're taking that water out and ignoring it. We just want to know how much we need to get that extra 15,000. So we know that our volume equals our surface area times our height or our amount of rain. So H is what we're actually going to find. So that is our amount of rain given in meters. So our volume is 15,000 because that's what we want. And we know that our area is 16,800 square meters. And that's going to be multiplied by height. So we've got the V equals AH. 15,000 equals 16,800 times H. All you're going to do is solve for H. So we want to rearrange this so that H is your subject. So we divide both sides by 16,800. And that will give us H. Chuck that into your calculator, and you will find that H will equal 0.892, blah, 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 blah. And if you round that off, you're going to get 0.893, which is in meters. So if we convert that to millimeters, you're going to get 893 millimeters because we just times by 1,000. And that's about it. So I hope that made a bit of sense. If not, drop me another line and I'll have a look at it again.